Hello, welcome to some PyTorch fundamentals. I'm going to go over tensors and basic operations, some automatic differentiation, data sets. We will try to build up a small neural network. We will go over training and how to save a model and how to do some basic visualization. Now, PyTorch is pretty much the go-to library in machine learning nowadays. So I believe that it's pretty important to at least like know what is it about all about and why is it really useful and to be able to I need to go over some Torch documentations or like ask ChatGPT about PyTorch if I don't understand about this thing. So PyTorch is pretty much like a it is neural network library, but it's more like a linear algebra library, like because in the end of the day, neural networks are also kind of like just linear algebra. So in order to set it up in Colab, in Colab it's pretty easy because it's already like everything is in the environment. So you just import some bunch of stuff. Um, we are importing like NN from Torch to build up some neural networks. And for the data sets and data loaders, and we're importing them from torch.utils.data, and we are like importing PyPlot from Matplotlib to like make some basic graphs. Actually, before that, oh yeah, you can pretty much like create any like matrices and like vectors with PyTorch. So you can create a tensor like this, which kind of just transforms the lists into a tensor. If I, let's say, um, if I run this and if I say X, now I'm gonna see that this is like a tensor now. So I can send that to GPU for parallel processing automated by Torch instead of like just writing CUDA or something like that. It's pretty cool, right? And after like you create whatever like matrix you want, you can print them out and like check out if this is actually what you wanted. And then what we're doing in here is you're reshaping the matrices in the way that you want, which is going to be very important when you're working with any neural networks. You will need to be able to like reshape them, the matrices and vectors, so that you can do whatever operation you want, or you can do whatever neural network you want to build up. So let's go over to the AutoGrad, which is really cool because like you might know that in neural networks in the gradient based optimization, pretty much like you're calculating the derivative of the loss based on the weights, and then you're doing like a kind of a little bit walkthrough to the weight of the weights so that they kind of start to learn to do stuff. And of course, implementing that, writing the equations and like writing all of the code is possible, but it's very time consuming and like very automatable. So what Torch does is great. Like it just can create, can like get the um, can calculate the um, any of its like derivatives numerically very fast, very parallel. So that's like I think why is it so popular? Like you see that it's like all of them are like just calculated with one line of code instead of like going over the equations and derivatives and stuff like that. Okay, no, there's a problem. Generated. let's not do this. Yeah. Let's just go over to create a tiny MLP now. You all know that like an MLP is just like a bunch of perceptrons stacked together. But in here, what we can pretty much do is that you can create those like fully connected layers automatically instead of just um, instead of like writing them with the perceptrons and such. So in here, our class TinyMLP gets the NN module, so it becomes like a neural network. So it's going to have all the properties of neural networks in the Torch system, which are going to be very useful when you like try to manipulate the layers or anything. Um, so in here, the NN module already have the fully connected layer and some activation functions. So you can pretty much implement the little MLP just by defining it like that. Now, after you define your class, you get your model, you put that into the device, which in this case, our device is what is it? CPU. But if you have your a GPU access to in your system, you will be able to just put anything, say to the to device, and it's going to send over to GPU, and Torch is going to do the optimizations for you. It's not going to be as good always, but like, of course, you're not going to write always like GPU programs every time. So I guess like that's it for today. Um, have a nice day.